Hi, I wanted to create a quick video on some of the functions we've been studying this week. The first of those is the greatest integer function. This function takes an input x and gives us out the greatest integer not greater than x. So for instance, if I gave the function f the input of 2.1, I would go on the number line to 2.1 and I would look immediately to the left of it for the integer that is the largest without being bigger than 2.1. So just to the left of it, there is 2 for my integer. So the output would be 2. If I gave it f 4.3, I go to where 4.3 would be, the integer that is the largest without being larger than 4.3 would be 4. So the output would be 4. It's a little interesting when we go with negative inputs. If I give, oh, that's not what I wanted to move. There we go. If I gave f negative 3.2, so negative 1, negative 2, negative 3.2, about there, the integer that is the largest without being bigger than 3.2 would still be immediately to the left of it. It would be negative 4. Now a real interesting one is if I was to give this f of, let's say, 3. So if I go where 3 is, the integer that is the largest without being larger than 3 is actually 3, because 3 is not larger than 3, so the output would be 3. Now this gives us an interesting thought process. This function operates on a whole wide set of inputs for a given output. For instance, when x is between, so greater than or equal to 3 and up to 4, f of x would have the same output. It would have an output of 3, because anywhere in that set of values, I keep grabbing the wrong thing, sorry. Anywhere from 3 up until 4, the greatest integer not greater than the input would be 3. And then at 4, and all the way up to 5, the output would be 4. So at 4, and up until 5, f of x would have an output of 4. And then at 5, you guessed it, up till 6, f of x would have the same output again of 5. Okay, so let's take a look at what this graph would look like. Okay, so here we've done a little bit of an interesting twist to this. Okay, I'm going to take the output of the greatest integer function and now I'm going to actually multiply it by negative 2. So let's say I have my outputs for x, well, let's go input for x, greater than or equal to 0, less than 1. Well, for all of those, the greatest integer output would be 0. Okay, because that's just to the left of any of those inputs. 0 times negative 2 would give me out 0. Then at 1, up to 2, but not including 2, the greatest integer would give me out 1. And then 1 times negative 2 would be negative 2. And then I go from 2 up until 3, the greatest integer output would be 2 multiplied by negative 2 would be negative 4. Okay, so let's graph those. So from 0 up until 1, the output is 0. So I'm going to put a solid dot at 0 because we're including that. Open dot at 1, and then I connect it. Okay, it's like a step function here. Then from 1 up until 2, the output was negative 2. So down here at 1, we get output of negative 2, and that goes all the way up until x is 2. And I connect those. It doesn't include 2, because at 2, the output drops down to negative 4. includes that, and then moves all the way over up until x is 3. And we can kind of predict a pattern. We could just continue with this pattern if we wanted to. And I could even go the other way. You can kind of see this pattern happening here. Okay? So that's how this greatest integer function is going to work. We see what is the output from the greatest integer, and then in this case, I was then multiplying that by -2. Okay? Now the next function that people were a little bit overwhelmed with was the absolute value function. And in this case, we're not going to look at any of the rules with stretching, compressing, horizontal and vertical shifts and all that. I simply want you just to do this with an input-output table. Okay? So I'm going to grab some input values at random. And then I'm going to plug them into my function and get outputs. So I put in -2, absolute value of -2 is 2, times 1/2 is 1, plus 1 is 3. Put in -1, absolute value of -1 is 1, times 1/2 is 1/2, plus 1 is 1.5. 0, that's going to give me an output of 1. Put in 1, I get an output of 1.5. Put in 2, I get an output again of 3. That doesn't seem right. That would be an output. I made a mistake there. Sorry. Even back here, -2. Absolute value of that is 2 times 1/2 is 1 plus 1 is 2. Sorry about that. And the same thing with +2. And notice the symmetry that's going on here with the inputs and outputs. We can definitely use that to speed up this whole graphing process. So now I'll go to -2, 2, and I'll put a point there. -1, 1.5, 0, 1, 1, 1.5, 2, 2. Okay, great. And we'll go ahead and draw the graph in here, and absolute value functions will be this V-type shape. It's not a parabola like a quadratic, it's a V-type shape. And there's the graph, and that's all about all I want you to do with these, okay? Then next up, we have a couple of word problem situations. I was wanting you to write inequalities with these, or functions or equations for the given information. This first one states that the acceptable temperature range to store refrigerated foods is between 34 degrees and 40 degrees Fahrenheit. Therefore, the temperature of a refrigerator may be within 3-degree range of 37 degrees Fahrenheit. Outside this range, and food either begins to freeze or spoil. So this is a tolerance problem, which is actually a absolute value inequality type situation. And the way we always set these up is inside the absolute value, I'm going to take the difference of the actual temperature, call that T, the difference of that and the ideal temperature has to be less than or equal to our tolerance. I can't write. Tolerance. Okay, so in this case, we'll have the absolute value of T minus the ideal temperature for this is 37 degrees. That's our middle of it all. Has to be less than or equal to the tolerance. Okay, and that is within 3 degrees of the situation. Okay, so if you see this type of situation where it can be a plus or minus a certain amount, that's a tolerance equation. Next one, a credit card company is running a rewards program in which its card members can earn 1 reward point for every dollar they spend using their credit card. Points are only awarded in whole number increments for each whole dollar spent. Therefore, if a person spends $1 using her card, she earns 1 reward point. But if she spends $1.70, she'll only earn 1 reward point. This sounds an awful lot like our previous function using the greatest integer situation. So we're going to just try that out and see if it works. F of x equals the greatest integer function on x. So let's see if that works. If I did f of 1, yeah, the greatest integer for that would be 1. That works. F of 1.7, greatest integer, not greater than 1.7 is 1. And if I did something like f of $100.30, that would be greatest integer, not larger than 100.3 is 100. So that would work. So this is a greatest integer function. Okay? I hope that helps a little bit. If you still have questions, make sure to come and talk to me.